All right, let's dive in. Today, we're talking about something that's, well, absolutely critical if you're a data scientist moving into a more production-focused engineering role, and that's MLOps security. We're going to shift how you think about protecting your ML projects, taking them from just a model that works to a real, secure fortress. So let's get right to it. Okay, picture this. You've done all the hard work, right? You've trained your model, it's performing like a dream, and you finally push it to production. It's live, it's serving predictions, but have you stopped to ask yourself, is this thing actually secure? Or is all that hard work, and maybe your company's most sensitive data, just sitting out there like a sitting duck? It's a huge question and one we absolutely have to tackle. So, here's our game plan for today. First, we're going to talk about why security is really your job. Then, we'll look at the most common threats you're likely to run into. And after that, we'll get practical, getting our hands dirty with two awesome tools, Bandit and Dependabot, to build out a security toolkit you can actually use. Super straightforward path from what's the problem to how do I fix it? First up, let's get our mindset right. This is foundational. Security isn't some extra feature you bolt on at the end if you have time. It's not a nice to have. It is a core responsibility. For any serious project, it's totally non-negotiable. So when we even say software security, what does that actually mean? Well, think of it as a true engineering discipline. It's all about being proactive, designing and building your apps so they can defend themselves. You're not just reacting and fixing bugs after the fact. No, you're building a system that's designed from the ground up to stand up to malicious attacks. And why is this so unbelievably critical? Well, the stakes are they're incredibly high. We're talking about protecting sensitive user data. We're talking about maintaining the trust that is literally the foundation of your company's reputation, not to mention complying with huge regulations like GDPR or HIPAA. A breach? It isn't just about fines. It can completely destroy customer confidence and even knock your services offline. Okay, so we've established the why, and now let's dig into the what. What are the actual threats you need to be on the lookout for? Think of this next part as your field guide to the vulnerabilities lurking out there in the MLOps world. Okay, threat number one. The single biggest, and I mean by far the most common threat, comes from your dependencies. You know, every single open source library you bring in with a simple pip install, well, each one could be carrying hidden vulnerabilities. It's an instant potential attack vector. And this quote just hits the nail on the head. You can write the most beautiful, secure code on the planet, but if you import one little library that has a known security hole, boom, you've just thrown the back door wide open. It's so true. Your project is only as secure as its weakest dependency. Of course, it's not just about dependencies. We also see all the classic software security risks. Stuff like, not validating your inputs properly, which can open you up to injection attacks, or insecure secrets management. And come on, we've all been tempted to just hard code an API key in a script to get it working, right? These are such easy mistakes to make, but man, the consequences can be absolutely devastating. But MLOps brings a whole new class of threats to the table, its own unique flavor of risk. In this world, the model itself and the data you trained it on, they become brand new attack surfaces. And this is where the work you do as a data scientist is most exposed. And these threats are both fascinating and kind of scary. Take model poisoning. An attacker could sneakily corrupt your training data just enough to make your model fail in very specific, targeted ways. Then there's data leakage, where your model's predictions accidentally give away sensitive info it was trained on. And inference attacks, that's where someone can actually start to reverse engineer your model or even parts of your training data just by cleverly asking it questions. Okay, enough about the problems. Let's start building that fortress we talked about. And our very first line of defense, it's all about securing the code that we write. And the best way to do that is with something called static code analysis. So let me introduce you to Bandit. It's this fantastic tool. Think of it like a linter for your Python code, but one that's totally focused on security. It just scans your scripts and finds common security no-nos, like using unsafe libraries or, hard coding passwords. And you know what? Integrating it is really straightforward. You can configure it directly inside your pyproject.tom file. So right here, all we're doing is telling Bandit, hey, scan my source directory. We're also telling it to skip a specific check we don't need, in this case, B101, and to please ignore our test folder. It's that simple. It's declarative, and it makes sure your security checks are the same for everyone, every time. Now, the real power of Bandit is that it's a static analysis tool. What does that mean? It means it finds these potential security holes before your code is even run. Think about that. That is a massive advantage. It lets you catch and fix problems way, way early in the game, long before they ever get a chance to do any damage in production. Okay, so we've used Bandit to lock down our own code. Awesome. But what about all those other libraries we're pulling in? You know, the dependencies. Well, for that, we need to turn to automation. And this is where GitHub's Dependabot is going to become your absolute best friend. Seriously. It's a feature that's already built into GitHub, and it just constantly monitors every dependency in your project. The second it finds a library with a newly discovered vulnerability, guess what it does? It automatically opens a pull request for you to update that library to a safe version. It's amazing. And setting it up? It's as easy as just adding one single file to your repository. That's it. This little YAML file just tells Dependabot, hey, I'm using pip for my packages, and I'd like you to check for updates daily. You just set it up once, and then it works tirelessly in the background, keeping you protected. I mean, let's be realistic for a second. You are not going to manually check every single one of your dependencies for new security holes every single day. It's impossible. Automation is truly the only way you can scale this. It's the only way to keep the very foundation of your project secure over the long haul. All right, let's bring it all home. We've looked at two really powerful tools. Now, let's see how they fit together to create a really solid, robust security strategy. You can really just think of it as a simple two-step security protocol. Step 1, analyze your own code. Use Bandit to keep your Python scripts clean. Step 2, manage your dependencies. Use Dependabot to automatically secure all the third-party code you're bringing in. It's a classic defense in-depth approach. And it's so important to remember this. Neither one of these tools is enough on its own. A truly robust defense only comes when you combine the static analysis of your code with the automated management of their code. When you do that, you're covering threats from the inside and the outside. And that is how you build the fortress we mentioned at the very beginning. By putting Bandit and Dependabot together, you create this powerful automated system, a really robust defense against the most common security threats you're going to face in the MLOps world. So I'll just leave you with this one question to think about for your own projects. Is security a feature that you're actively building, or is it a vulnerability that you're just passively ignoring? Because as you make that move into engineering, your answer to that question is going to define the resilience of everything you build.